Hello guys, how are you today? So today I'll be explaining the physics periodic course practice from section 2.19 till 2.23. So let's starting with the first question. The current through a 50 this is our resistance, conductor is 2 amperes. This over here is our current. They need the potential difference across this conductor. Potential difference always means the voltage. And for us to find the voltage, we know that the equation is V is equal to R times I. Alright, so to find the potential difference, which is the voltage in this case, we will say V is equal to R, which is 50 in this case, times our current I, which is 2, which in total is 100 volts. Now, of course, you have to change the units to the SI units, the ones that are always used. Now, the amount of heat liberated in this conductor in 3 minutes. What do they mean by amount of heat liberated? This means the energy used, which we denote by Q or E, however you would like to denote it, it doesn't matter. So, Q or E is equal to I times V times T. We have our current, which is 2, multiplied by our voltage, which is 100, multiplied by the time, but we are given the time in minutes, so we have to change it into seconds. So to change it from minutes into seconds, we are going to multiply by 60, so we get 180 seconds. So 2 times 100 times 180 will give us an answer of 36,000, but this is in joules. However, if you notice, they needed it in kilojoules. So how do we change from joules to kilojoules? We divide by 10 to the power of 3. So 36,000 divided by 10 to the power of 3, we will be left with 36 kilojoules as our final answer. Moving on to question number 2. The diagrams below describe circuits in which the current and potential difference can be controlled. Okay? Now, how do we know which one is used to control the current and which one is used to control the potential difference? Very simply, by looking at it, okay, we can notice two things in this one. First of all, it is connected in series, and always it has to be connected in series if we are going to be measuring what? The current. And another thing is that it is smaller. So, the smaller one that is connected in series is used to measure the current. Okay, that means A is used to measure the current, not only to measure, but also to affect and change it. Whereas B, if you notice, it is placed in parallel. And when we are talking about parallel, we usually talk about the voltage or potential difference. And as well, you notice that it is a bit bigger. So if it is bigger, connected in parallel, then it will measure the voltage or potential difference. So in this case, A is used to control the current or measure and control the current, and B is used to control or measure the potential difference. Moving on to question number 3. Now, the graph below shows how the potential difference across a circuit device varies with current going through it. Now, let me just show you images of the graphs, the IV graphs. Pay attention. IV, hold on. IV and not VI graphs. This is a mistake I did last time, that they need the VI graph. They gave us the voltage current graph and not the IV graph. So I'm just gonna get them for you. So as you can see in this diagram over here, we are given what? We are given the IV graph. So pay attention if it's VI or IV graph. Okay? Now, what we need to know, I'm just gonna block out the ones we don't need. We don't need the gas discharge tube. And we do not need a thermonic diode and thermistor. I believe that they want us to take it like this. So hold on a second, let me just fix it up. So like this. So these are some of the graphs that might come to us. We have a filament lamp, looks like this. Thermistor, I prefer not to use this one here. I will draw for you what the thermistor is supposed to look like on the side. So again, we are dealing with an IV graph, and we said we are dealing a thermistor, so it's gonna be the opposite of a filament lamp, and it's gonna look something like this. Okay, then we have a semiconducting diode. It's down, then all the way it goes up. It's like some asymptotes. And then finally we have an ohmic conductor. So you need to memorize 1, 2, 3, and 4. This is for the thermistor. So please do memorize these graphs. Alright, so as we said, we have to pay attention on whether it is a VI graph or an IV graph. In this case, it is what? A VI graph. So whatever we saw in the graphs before, we are gonna flip them. So let's take into consideration a filament lamp. Filament lamp, we are talking about VI, no longer IV. So it's gonna be the total opposite. If before the filament lamp was, I believe like this, okay? Then by the VI graph, it's gonna be like, hold on. It's gonna be like this by the IV graph. Or sorry, the VI graph, it is gonna look like this. Whereas if we are dealing with, let us say a thermistor, we are dealing with a VI graph, it's gonna be the complete opposite. So originally it is like this. Okay, but because it is a VI graph, it's gonna be, oppositely, and I apologize, I keep on drawing it wrong. So this is what the thermistor VI graph looks like. So that means by looking at this graph, as you can see, it kind of reminds us of what? Of the VI graph of a thermistor, which looks like this. Yeah? So that means this belongs to what? A thermistor, or this circuit element belongs to a thermistor. Now, pay attention to this. For low currents, when they say low currents, then we are definitely gonna choose a low current. They need the resistance of the circuit element. Very simply, we know that resistance R is equal to the voltage V over the current I. So if you choose any point, any single point, for example, 0.1 and 5. So R is equal to a voltage of 5 over a current of 0.1. If we do it on the calculator, we are then gonna get an answer of 50. So pay attention, they said for low currents, so you are gonna choose the low currents. So over here it is 50 ohm. Moving on to question number 4. In the diagram below, the resistance of resistor 1 is 60 ohm. So let's keep in mind, here we have 60 ohm. The resistance of resistor 2 is 30 ohm, and the resistance of resistor 3 is 50 ohm. And the potential difference of the battery is 14 volts. They need the equivalent resistance of resistor 1 and 2. We know resistor 1 is 60, resistor 2 is 30. They need the equivalent resistance, and if you notice, they are placed in parallel. So when we are dealing with resistors in parallel and we need to find their R equivalent, then we are gonna do that 1 over R equivalent is equal to 1 over resistor 1, which in this case is 60, plus 1 over resistor 2, which in this case is 30, and etc. Now, you can do it this way. However, in the case that you have 2 and only 2 placed in parallel, then you can find it easily by doing 60 times 30. So their product divided by their sum divided by 60 plus 30. So however way you do it, or whichever way you do it, you are gonna get the same answer, which in this case is gonna be 20. So the equivalent resistance of resistor 1 and resistor 2 is 20. Now they need the total resistance of the circuit. So very simply, we know that the equivalent resistance of this is 20 ohm, and we know that this resistance is 50 ohm. And since they are now in series, so if we draw it again, it's gonna be like this, and then battery. Okay, we are gonna have 20 ohms and 50 ohms. Now, since they are in series and we need to find their R equivalent, we very simply just need to add them. So we will get an answer of 70 ohms. The current passing through resistor 3 is how much? Very simply, we know that the current is the same if it is in series. So I is same in series but splits in parallel. Whereas the voltage V splits in series but is same in parallel. So keep this in mind while we are solving this. Okay, so we got a total resistance of what? Of 70 ohm. So we know that we can find the current I if we take the potential difference V, okay, and we divide it by our resistance, because the equation is V is equal to R over I. V, our voltage, is 14. Oh, sorry, I did a mistake. Wait. V is equal to R times I. My apologies. So again, V is equal to R times I. Okay, and we've got what? We have a resistance of 70 ohm. Okay, and a current I that we need to find. And we are also given a voltage V of 14 volts. So very simply, to find I, we are going to do voltage divided by the resistance. So then that means I is equal to 14 over 70. If you do it on your calculator, you are going to get an answer of 0.2. So the current, the total current passing through the circuit is 0.2. That means in this, because it's parallel, we're going to leave it aside. But if we are going to take the equivalent, the R equivalent, or the equivalent resistance, which is 20, okay, we are going to say that the current passing through this 20 resistance is how much? Is 0.2. The current passing through this 50 resistance is how much? It is 0.2. So we found the current passing through resistor 3 to be 0.2 amperes. Now they need the potential difference across resistor 3. Okay, to find the potential difference across resistor 3, we are going to take the resistance of resistor 3, which is 50, the current that passes into resistance 3, into resistor 3, which is, how much was it? 0.2. And very simply, to find the potential difference, which is V, we are going to do R times I. So V is equal to 50 times 0.2, which is then 10. So the potential difference is 10 volts. Moving on to question number 5. Okay, this one, I don't think it will come to us as a question, but it is nice to solve. Okay, the voltmeter measures a maximum voltage of 10 volts. This is what? This is voltage initial. Its resistance is 2 kilo ohms, so 2000 ohm. A shunt resistance is used to modify its scale so that the voltmeter can read a maximum voltage of 50 volts. So this is what? This is voltage final. They need us to find, first of all, the shunt resistor should be connected in what with the voltmeter. When we are dealing with a voltmeter, we know that it is placed in parallel, and always the shunt resistor is placed in an opposing direction to the device we are using. So if the voltmeter is parallel, that means it is placed in series. Now, to find the resistance of the shunt resistor, the first thing is we are going to find what? The initial current. So current initial, it is going to be the voltage, the initial voltage, which is 10, divided by the initial resistance, which is 2000 ohm. We are going to get an answer of Alright, and so then we will get 5 times 10 to the power of minus 3. So this is what? This is our initial current. Now what are we going to do with this initial current? We are going to take the final voltage, because we know it's placed in series. So the current is going to be the same everywhere. So no matter what the voltage is, the current is going to be the same. We are going to take our final voltage, which is 50 volts, and we are going to divide it by our current, which is 5 times 10 to the power of minus 3. And we are going to get an answer of 10,000. Now this is what? This is our resistance final. However, to find the resistance of the shunt resistor, we are going to take 10,000, which is the final resistance, and we are going to subtract it from the original resistance, which is 2,000, and we will get 8,000 ohm, or since they need it in kilo ohm, it is going to be then 8 kilo ohm. So this is series, and this is 8 kilo ohm. Moving on to question number 6. Consider the circuit shown in the diagram below. The bulb in the circuits are identical. What will happen to the brightness of bulb 1 and the brightness of bulb 2? Now, very simply, we know that if they are placed in parallel, then they have different. So again, as I was saying, if we are talking about parallel, or like two bulbs are placed in parallel, then they have a different current passing through them. However, they have a same potential difference passing through them. If they are in series, then they have the same current passing through them and a different, I forgot how to write, different potential difference passing through them. So in this case, how do we know if they are in series or in parallel? Basically, draw or trace the two lines. If they both form a curve or they both change direction, that means they are placed in parallel. Okay, same goes here. You see it will curve, it will form a 90-degree. Whereas to see if they are in series, we're gonna apply the same thing, but as you can see, there is no curve, so it's a straight line. That means they are in series. Now, the brightness of bulbs depends on the current that passes through them. So definitely, the current passing through one is a bit, way stronger than the current passing through two. Because to be honest, the current always is passing from the positive side all the way to the negative side. So the first bulb is getting the biggest current, okay? And since it is placed in parallel with bulb 2, that means the one closer to the battery is gonna get a bigger current. Now, for 3 and 4, because they are placed in series, they are gonna get the same current passing through them, so their brightness is gonna be the same. So bulb 1 will have a greater brightness than bulb 2 because it is in parallel with bulb 2 and is closer to the battery. Bulb 3 is equal to the brightness of bulb 4 because they are in series. Now, no current will flow in the circuit if which bulb is unscrewed. Let us try. If we try with bulb 4, we know that first of all the current's objective is to flow from the positive side to the negative side. So if you remove bulb 4 or even bulb 3, it still has a pathway to pass through. However, if you remove bulb number 2, it can still find a pathway to pass through. Whereas if you were to remove bulb 1, it will come here, but it will stop. So bulb 1 is unscrewed. Okay, if it is unscrewed, then no current will flow and all the bulbs are gonna be off. Now, consider the circuit shown in the diagram below. The bulbs in the circuit are identical. This is a good thing. Since they are identical, that means it's gonna be proportional in some sense or similar. They're divided equally if you want. So they said if you unscrewed bulb 2, the brightness of bulb 1, so look what happens. Bulb 2, brightness of bulb 1, will it get affected? As you can see, it is not affected because it's literally passing and it will go from the positive side. The current will flow from the positive side to the negative side and it will not be affected, so it remains the same. Whereas the brightness of bulb 3, so again we removed bulb 2, look at the current. The current will pass from here, but because bulb 2 is removed, there is no current to be passing through bulb 3. It's an open circuit at the bottom. So no current will pass in bulb 3. Okay? And that means that its brightness will become 0. Alright, so we move on to question number 8. The potential difference, this means the voltage across a 50 ohm, 5 ohm, not 50. Again, 5 ohm, this is our resistance of resistor 20 volts. This is, again, our voltage is potential difference. They need the power consumed by this resistor. What you need to know is that power is equal to the current times the voltage. In this equation, you can memorize it or you can memorize all its other forms, but this is personally how I do it. Power is equal to current times voltage, okay? We are given what? We are given the voltage and resistance, so we need to find the current. We have voltage, we just need to find the current. Very simply, to find the current, we know that I is equal to V over R. So V is what? V is 20 divided by R, which is 5, is equal to 4. So we get a current of 4. So 4 times the voltage, which is 20, will give us our power. So our power is equal to 80. You can do it like this, or you can memorize the equations that, okay, we have resistance and we have voltage. So power is equal to resistance, to voltage squared over resistance. And we will get an answer of 80 as well. So whichever way you like, I prefer this way personally, but it is up to you. So 80 watts. Moving on to question number 9. We have two resistors of resistances 30 ohm and 70 ohm are connected in parallel. They need us to find the equivalent resistance. So to find equivalent resistance and they are connected in parallel, we apply this equation. 1 over Req is equal to 1 over R1 plus 1 over R2, etc. But as long this is the case only and only if you have two resistors, you will have their product on top, so 30 times 70 divided by their sum, which is 30 plus 70. So if you do it on the calculator, 30 times 70 over 30 plus 70, you will get an answer of 21. Or if you do 1 over 30 plus 1 over 70, you are gonna get then 1 over 21, and you are gonna flip it to get an answer of 21. So the equivalent resistance in general is just 21. Moving on to question number 10, we have three resistors, 15, 20, and 50 ohm, are in series. To find their equivalent resistance, we just need to add. So 15 plus 20 plus 50 will give us an answer of 85. So our answer over here is 85. Moving on to question number 11. A current of 3 ampere flows in 20 resistance or ohm resistor for 1.5 minutes. They need the amount of energy. What is the amount of energy? We said again Q or E, however you denote it. So Q is equal to I times V times the time in seconds. We are given what? Our current, I. We have resistance R and we have our time. So we will just change it to seconds by multiplying by 60. We will get an answer of 90. Now, we have I, we have T, but we are looking for V, and we know that V is equal to R times I. So, V, our potential difference, is equal to the R 20 times the current I 3, so 60. So now we have a current I, which is 3, times a voltage V, which is 60, times the time, which is 90. So 3 times 60 times 90, we will get an answer of 16,200, and approximately it is, they're gonna take it as 16,000. So to the nearest 1,000 they are taking it. So they took it as 16,000, and they changed it from joules. In this case it is joules. They changed it to kilojoules. So it's gonna be then 16 kilojoules. Moving on to question number 12. Again, you have to memorize the graphs. So this is an IV graph. Pay attention. It is an IV graph. There is a difference between VI and IV graph. Okay, so this is the graph of a semiconducting diode. So let me just go back and show you. As you can see over here. So this is what the semiconducting diode graph looks like, something like this. And filament lamp looks like this. This is, we're talking IV graph. Thermistor, they don't want us to memorize it like this, just memorize it like this. And then we have the ohmic conductor or the ohmic conductor, which is a straight line passing through the origin. So this is the semiconducting diode, and this is an ohmic conductor, which is a straight line passing through the origin. Now we move on to the last question. So in the diagram below, the potential difference across the battery is 24 volts. Okay, I wrote 2 volts, I meant to write 24 volts. The resistance of each of resistors A and B is 10 ohm. So we have 10 ohm here and 10 ohm here. And C is 45 ohm. The current through the resistor C to 2 decimal places is. Now, very simply in this question, what we need to do is we need to find the total equivalent resistance. So first we can do that by finding the equivalent resistance of these two parallel. So you can apply the 1 over Req is equal to 1 over R1 plus R2 plus etc. Or you can do their product. So 10 times 10 divided by 10 plus 10. So if you do it on your calculator, you will get an answer of 5. So 5 ohm. Okay, so we have 5 ohm and 45 ohm. We can find equivalent resistance by adding them because they are in series. So we get 50 ohm. Now to find the current in the circuit, okay, we are going to take the voltage, which is 24, and divide it by 50 ohm. So 24 divided by 50, we will get an answer of 0.48 current. Now, it is passing. It's going to be passing the same if it is in series, but it will split in parallel because we are talking about the current. So they asked us for the current in resistor C. It is going to be the general current, which is 0.48. Now to find the current through resistor A to 2 decimal places, very simply, we can do this in many ways, but a really preferable way that will work for all cases is this. We are gonna find the voltage consumed by resistor C, okay? And again, we are gonna take this as Req, which is 5 ohm, okay? But first we need to find the voltage in resistor C. So we know that voltage is equal to resistance times current. The current is 0.48 and the resistance here is 45. So 45 times 0.48, we are gonna get an answer of 21.6. So 21.6 volts were used over here. And the total voltage is 24 volts. And we know that that the voltage in series is additive. So if this is 21.6 and the total is 24, then the total, or the one consumed by the 5 ohm, is gonna be what? It is gonna be 24 minus 21.6, which is then 2.4. Now 2.4 is consumed by 5 ohm, or since they are in parallel, we know that the voltage is gonna be the same. So 2.4 volts here and 2.4 volts here. So now, to find the current passing through this and this, we are gonna take the voltage, 2.4, and divide it by their resistance, which is 10, and we will get an answer of 0.24. So here the answer is 0.24. Let's submit and hopefully there are no mistakes. And thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.